Hi guys, welcome. Today we are looking at day 7, math 7. So we're going to be going over lessons 44, 45, and 46. Again, things will start slowing down here in a little bit. A lot of this hopefully still is review. So lesson 44, if you want to turn there, page 338, we're looking at division answers. Again, way back in elementary school, we're taught to divide until we can't put a number into another number evenly. So we would have what's called a remainder. So we used to write our numbers like that. No longer are we going to be doing that. We're either going to put it in a mixed number form where we have a fraction, a whole number in a fraction, or where we have a decimal. Okay, so if we have 54 divided by 4, divided by 4, well, 4 goes into 5 once, with 1 left over, goes into 14 3 times, with, that would be 12, so there would be 2 left over. So if we're putting in a remainder, which we're not, okay, just to kind of review, we will leave it as 2. We have 13 and 2 left over. Well, now we know that remaining 2 is being divided by 4, so we'd write as 13 and 2/4. 2 over 4 reduces down to 1/2. So 13 and 1/2, or if we were doing it as a decimal, and 1 with 1 left over, 3, then we would put in the decimal and there would be 2 left over, and then we would add the 0 because we're moving to the right. 4 goes into 0 5 times. 5 times 4 is 20, so we don't have to keep going on. Our decimal terminates right there. So 13.5. So again, remainder is the old way we used to do it way back when, but now we're either going to be writing it as a mixed number or a decimal until it either terminates or it starts repeating, which we've talked a little bit about that before as well. Okay, so if we have 37.4 divided by 9, okay, 9 doesn't go into 3, so we don't do anything there. It does go into 37 4 times, which is 36. So we have 1 left over. Now we're moving into our decimal place, so we make sure in our answer we include that. 9 goes into 14 only once, which is 9. 14 minus 9 gives us 5. 9 goes into 50 5 times, which is 45, which is going to give us 5. Okay, so this is going to keep repeating. So we put the bar over there, but if we round to the 10th, we know it's going to keep going on with that same pattern forever. So 4.15, the value to the right is a 5, so that means we round this up. So the rounded to 2 decimal places would be 4.16. Okay, let's look at example 3. It says vans will be used to transport 27 students on a field trip. Each can hold 6 students. How many vans can be filled? Well, 6 goes into 27 4 times, which is 24. So we would have 3 students left over. So B, how many vans will be needed? Well, we can't just send those 3 students home, or we can't have them right on top of the van or anything like that. So we're going to have to get a 5th van. So in this real world example, we can't have halves or decimal places or fractions or anything like that because we can't, divide that up. We have 3 students that need a van as well. So we can then divide up the 27 into the 5 vans, however we want. If all but 1 van will be filled, then how many students will be in the van that will not be full? Well, the remainder, as we said, was 3. So those are 3 students that are going to be in the 5th van. Okay. Practice set we'll go over when we return. Lesson 45, we're dividing by a decimal number. So this one especially as we're still not using a calculator. Once we get into using calculators, we can just perform the calculation pretty quickly and easily in our calculator, but this is an important concept to know. So let's look at $2 divided by 25 cents, or 2 divided by 0.25. If we have that, one thing that we can do when we have these decimal numbers is we can move them over. But if we do it to the numerator or our dividend, our denominator, and our divisor, we also have to move the decimal. It just makes it a little bit easier. So let's do so what if I said 1.2 divided by 0.4? Oh, I mean, we could do 0.4, 0.8, and kind of mentally do it. But another thing we can do is move the decimal, because we want to be dividing by a whole number. Okay, so I can move this to the right one time. If I do it to that number, I need to do it to this value as well. And what I'm essentially doing in this example is multiplying top and bottom by 10, which 10 over 10 is equivalent to 1. So I'm not changing the value of it. I'm just rewriting it, because now, after I do that, I can look at it as 12 divided by 4. Well, I don't know about you, but 12 divided by 4 is a lot easier than 1.2 divided by 0.4 to me. So then we have 12 divided by 4. Well, 4 goes into 12 3 times. So that's where we move that decimal number. So if we have it like this, let's say 0.15 divided by 15, or by 0.5. Okay, well, we want to be dividing by a whole number, so we can move this. Okay, one time to the right, or multiply both of them by 10. As long as I remember, I got to do it to both of my numbers. We'll be fine whichever form we have it in, and then we could go ahead and perform the calculation. Oh, well, 5 doesn't go into 1. 5 goes into 15 3 times, so then it would be 0.3. Okay, so it's going to be a little bit easier when we're dividing by a whole number. If this number is a decimal number, that's okay. It's just we want to be dividing by a whole number to make life easier. It's the same thing. We're not changing the value. So when we do that, like this example, 1.36 divided by 0.4, let's multiply top and bottom by 10, or move the decimal 1 to the right. Now we're dividing by a whole number, which is good. Just an example like that. And so example 2, if we have 0.144 divided by 0.8, again, we can put the zeros here. I usually don't, just out of habit, but it's the same as 0.144, 0.8. Okay, now we want to divide by a whole number. So whether I have it in my division box or as a fraction, I want to move the decimal to the right only one time in this example. So then I'm going to have to do the same thing right there. So now I have 1.44 divided by 8. Now, instead of saying, well, how many times does 0.8 go into 0.1? That just sounds weird. Well, 8, how many times does it go into 1? It doesn't, so that's 0. How many times does it go into 14? Once, which is 8, which gives me 6 left over. Then I drop down my 4. 8 goes into 64 8 times. So it's a lot easier, especially as we're doing it by hand. Once we get into the calculator, you don't need to do this, because we can just punch it as is and it'll calculate it for us. But for right now, especially as we do things by hand, this is going to be a great way to save us some time. And so just remember, we want to divide by a whole number. If the numerator, or the number we're dividing, is still a decimal, that's okay, because we know how to do that pretty simply. We just want to make sure that we're dividing by whole numbers. Okay, again, move the decimal how many times? Again, this example, we would move it 2 times. So in this one, we would also move it 2 times, and we get 35 times 20. $35 times 20 is 700. So it just makes it a little bit easier. And since we're moving both of them, or we're multiplying top and bottom by 10 over 10 or 100 over 100 or whatever, we're keeping it equivalent. Okay, and then 46, we're looking at a rate. So again, a rate is a ratio of two measures. So like miles per hour, we use that all the time. How fast were you driving on the trip? Or, how fast was the plane going? Another common one, miles per gallon. Okay, I get 30 miles per gallon in my car. I only get 15 miles per gallon in the truck or whatever. So that's miles per gallon. So we have miles and gallons, and we're comparing every mile per gallon, $12 per hour. How much do you make? That's one of the first things you want to know when you're applying for a job. Is it $10 an hour? Is it $50 an hour? Obviously, that's going to determine whether or not you want to take that job. So you can express it in words like this, or even acronyms, MPH, MPG, we commonly use. Or we can write them as fractions like this: 65 miles for every hour, 25 miles for every gallon, $12 for every hour. So that's just a rate. Okay, common one. Rate is distance over time, or distance equals rate times time. We can move this around to show elapsed time. Sometimes people remember it as, I've heard it referenced as the DIRT formula, because distance equals rate times time. Well, if I'm going 10 miles an hour and I traveled for 1 hour, the distance I've gone is 10 miles. Okay, so we can rewrite it in this form as well. All right, so Arnold drove 390 miles from Los Angeles to Sacramento in 6 hours. What was his average rate of speed? 390, 6 hours. Again, we want to know miles per hour because that's the rate we're going to use, not miles per 6 hours. So we have miles and hours. That's good. We don't have to convert our units. But what we can do is we can divide these. So we need to simplify this down. So 6 goes into 39, 6 times, 3 left over, and it goes into 35 times. So if we factor, that's a 1. If we factor a 6 out of both of these, or do 390 divided by 6, we're left with 65. And then 1 down here, we factor 6 out of 6, we have 1. So we don't get rid of hours or miles in this case, but we're left with 65 miles for every 1 hour. Okay, because that's what our speedometer is. That's what the speed limit signs are in, is miles per hour. So if we want to know how fast we were traveling, we want it in miles per hour. 65 miles per hour is how fast we were going. In working with money, Jared was paid $480 for 30 hours of work. What was Jared's hourly rate? Well, we would go in $480. We don't want to know for every 30 hours. We want to know for every hour. So we break it down by dividing. Again, assuming no overtime or bonuses or taxes being taken out, we're looking at $480 divided by 30 hours. We're going to keep dollars and hours, but then when we divide 480 divided by 30, we're left with 16 over 1. So we could leave it as this, or we could write it out in words. We have $16 per hour, or for every hour we make $16. We also have unit price. A lot of times things are sold in price per pound, $5 per pound, $2 per pound, or ounces for some smaller things. So if we look at a lot of examples here, let's look at example 5. Or no, where's one? I'll just use this one. Okay, example 4. What is the unit price of 24-ounce box of syrup priced at $3.60? So we do 3.6, 3.60 either way, divided by 24, and we get 0.15. And again, because 24 doesn't go into 3, but it goes into 36 once, with 8 left over, or 8 left over, then it goes into our remaining 5 times. So we have 15 cents for every ounce. Okay, so it's 15 cents per ounce. So we can just do division in this case, like in the other examples, to figure out our price per ounce. We'll also work with unit rates and converting. If we're talking about miles per hour, we want to know feet per second or something like that. We'll work on how to do that down the road as well. Okay, using our distance formula, if we have Felipe is planning a bicycle tour of the state with some friends, he estimates that they can ride 7 hours each day at 12 miles per hour. How far does Felipe estimate that they can ride? So 12 miles per hour for 7 hours. So when we're doing this and we're multiplying, so for 7 hours at 12 miles per hour, we're going to multiply these to get our distance, rate times time. So here's our time, here's our rate. We're going to multiply in any order. When we do this, okay, just like any number over itself is 1, 5 divided by 5 is 1, 1.2 divided by 1.2 is 1. It's the same thing with our units. So hours in the numerator and hours in the denominator, those are actually going to cancel out, and you'll see why here in a second. So hours and hours cancel out. I'm left with 7 times 12. What is that? 84. And I still have miles. I haven't got rid of that, but then I have over 1, or I can just write it as 84 miles. So the distance obviously is in miles. We're going to travel, if we can keep this pace, we're going to travel 84 miles per day. Okay, so when we multiply it out, we cancel out numerator and denominator, units, hours over hours cancel out. So we're left with just miles, which makes sense. Our distance that we're talking about is obviously going to be in miles, not miles per hour, because that's a rate. All right, we'll look at that practice set when we return to class together.